For our mini documentary assignment, we chose to focus on Kempton Run, which is a small stream found in Franklin County, Ohio, that is a tributary to the Olentangy River. Kempton Run is vital to its surrounding ecosystem as it drains approximately 1.5 square miles of land throughout Franklin County. The stream runs through popular recreational areas such as Indian Hills Swim Club, Sycamore Hills Swim Club, and Antrim Lake Park, and it's surrounded by houses. Unfortunately, water quality assessments conducted by the Ohio Environmental Protection Agency and members of FLOW, which is an acronym for Friends of the Lower Olentangy Watershed, have shown signs of poor water quality. Much like other bodies of water in the surrounding area, Kempton Run has been polluted by various chemicals as a result of urban runoff and agricultural runoff. Much of the urban runoff affecting Kempton Run is due to its proximity to the Ohio State University Airport, and much of the agricultural runoff is a factor of Kempton Run running through the Ohio State Beef Center, a cattle farm. Additionally, litter and erosion have caused the stream to become degraded. Consequently, there's a lack of biodiversity and poor water quality within the entire stream system.
In order to meet our restoration goals, we plan to perform different water quality tests in the Kempton Run stream in order to establish a baseline to go off of for restoration efforts. First, we decided that we would perform a Citizens Qualitative Habitat Evaluation Index, which would help us assess macro habitat quality in flowing waters. While collecting data from this form, we walked the entire length of the site to observe qualitative characteristics such as substrate, fish cover, stream morphology, bank riparian zone, and pool riffle run quality. We would also collect macroinvertebrates using a net along our 500-meter sample site, which we would compare to the Kempton Run Site A data just downstream that FLOW collected on April 23, 2021 at 11 a.m. This form is split up into 3 sections. Group 3 taxa, which represents species of high tolerance to pollution, Group 2 taxa, which represents slight tolerance, and Group 1 taxa, representing no tolerance to any pollution. As seen in FLOW's sample taken in 2021, they found 2 Group 1 taxa, 3 Group 2 taxa, and 2 Group 3 taxa, adding up to a stream assessment quality rating of 14, telling us that the river had fair quality cumulative index value. They were also able to tally a CQHEI score of 66, which provided good habitat for aquatic life. Finally, as we look at data collected in 2021, FLOW samplers recorded a water temperature of 14.3 degrees Celsius, TDS of 347 milligrams per liter, and conductivity of 700 microsiemens. We had past data to go off of, and next we had to compare our data to theirs. In our sample, we were able to find 2 Group 1 taxa, 2 Group 2 taxa, and 2 Group 3 taxa, adding up to a CIV score of 12, which also represented a fair rating of stream quality. We then tabulated data for the Citizens Qualitative Habitat Evaluation Index, adding up to 72 out of 100, which provided excellent habitat for aquatic life. Finally, we recorded a temp of 10.2 degrees Celsius, TDS of 403 milligrams per liter, and conductivity of 610 microsiemens. Using our data compared to FLOW's, we could conclude that the overall stream quality has improved since 2021, but still not ideal to support a wide variety of life.
When brainstorming our restoration goals for Kempton Run, we decided to divide up long-term, medium-term, and short-term outcomes. In terms of our long-term outcomes, we hope to see improvement of water conditions, including in the pH, salinity, turbidity, and temperature of the water, along with a decrease in the amount of pollution. Our medium-term outcomes include a higher concentration of aquatic species living in the stream. Specifically, we would like to see 5 species per cubic foot within 15 years, and at least 7 new species establishing themselves within that same time frame. We also hope to see turbidity drop to below 10 NTU within the 15-year time frame. Lastly, for our short-term outcomes, we want to see the establishment of a variety of substrates, such as flat rocks as opposed to sand or mud, that support different macroinvertebrates after 1 year. This can be achieved by importing these materials into the ecosystem. Furthermore, we desire to see the introduction of 3 different naturally occurring riparian vegetations after 3 years. This is essential because they are an important food source and breeding ground for macroinvertebrates. Our last short-term goal is to minimize erosion on stream banks by providing plant coverage. We plan to do this using grass filter strips, which have been known to slow runoff velocity and filter out pollutants. Within 5 years, we would like to have an average density of 4,000 plants per acre. In order to achieve these goals, we will return to our site every 6 months to evaluate how effective our selected restoration treatments are. If they are showing signs of promise, we will continue implementing them. However, if our treatments seem unsuccessful in allowing us to reach our goals, we will adapt that treatment and reassess the results at our next visit.